Okay, so this video is going to be on the probability series of OF2, and I'm going to start with what is probability. So let's say that I have a coin. So I toss this coin 100 times and I get 52 heads. That's the actual result. A question I could have asked though is how many heads should I have expected? And the answer to this would be we would expect 50 heads. So what is the reason for this? Well, on a coin there are two sides, a head and a tail. So we have a 1 in 2 chance of getting either outcome, and obviously a 1 in 2 chance means that they have equal probabilities. In another experiment, I throw a fair dice indefinitely. What I do is I keep a track of the proportion of throws which give a 5. So a question we could ask is what proportion of the throws will be 5? The answer is the probability that the outcome of getting a 5 is 1/6. So 1/6 is the proportion. The reason for this is on a fair die, and die is just the singular of dice, there are 6 possible outcomes, so 6 sides. The proportion of 5s we'd thus expect are 1/5 for every 6 throws. So this is where now it's all going to start making sense. In yet another experiment, I stop and start a stopwatch. Whenever I stop it, I write down the last digit. So a question I could ask is what is the probability that the last digit is an even number? And the answer is the probability of the outcome will be 1 in 2, 1/2. So what's the reason? Well, we have 10 possible outcomes. And what I'm going to do is I'm going to underline the, what did we want? We wanted the even numbers. So I'm going to underline the even numbers, 0, 2, 4, 6, and 8. And I'm going to highlight the odd numbers, so 1, 3, 5, 7, and 9. So of these, we can clearly see that 5 are odd and 5 are even. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And the probability is thus the number of desired outcomes. So obviously we wanted an even number, so we wanted the numbers from this list of possible outcomes. We wanted the numbers 0, 2, 4, 6, and 8. So obviously there's 5 desired outcomes. And let me just underline desired outcomes. And the total number of outcomes we can see above is 10. And therefore, if we divide the desired outcomes by the total number of outcomes, we get 5/10, which can be simplified to 1/2. The reason I said these would make more sense now is for a coin, we've got a heads or a tails. So the desired outcome was heads in this instance, and so we've got one desired outcome divided by the total outcomes, which is heads or tails, so the probability is 1/2, and this obviously can't be simplified. Similarly, in a fair dice, we've got 6 possible outcomes because we've got 6 sides. The probability of getting a 5, well, there's only one 5 in a fair dice, so no, not 5. So that means we've got one possible outcome of getting a 5 divided by the total possible number of outcomes, which is 1, 2, 3, 4, 5, and 6. Therefore, the total probability is 1/6. And again, this can't be simplified. So all in all, in each of the above cases, we have introduced randomness. And this randomness, however, is quantifiable. So it's not the kind of randomness in which most of us are accustomed to talking about, where there's no plausible reason for it occurring. And what we thus say is probability is the study of quantifiable randomness. So I hope this video has helped. I will be setting up my website soon. It should be www.mjtutorials.com. Of course, I've got my YouTube channel, Matthew James Tutorials. So if this video has helped, leave a like. Be much appreciated and definitely help my channel grow. If you have any questions or any suggestions even, just drop a comment below or to the side, the way YouTube's constantly changing. Of course, if this video was useless, you can feel free and leave a dislike. And yeah, if you want to check out my website, I will be posting all of my notes, both my original written notes in addition to my typed up notes. They will all be available for download. I will have examples eventually. I will have worked solutions, and yeah, it should just be a good learning resource to help you with your studies. Okay, thank you.